part one of a series, hopefully. And the aim of this is to create a tic-tac-toe game and to train it with various machine learning algorithms or AI algorithms. But not just that, I'm going to be all doing it with just .NET, even the machine learning and the training. So this part one, is where I'm going to create the game, hopelessly over-engineer it, and basically use WebAssembly to host it on the web so that we can actually play the game. And this is all just to lay the foundations for the good stuff coming, is to train the bots. So let's take a look at the code. And I've opened up the solution here in Rider, and there's several projects here. The most important one is the tic-tac-toe game. And this is basically the game state that I've built, and checks whether we win or lose, and dictates the gameplay, etc. Then to supplement that, I've got a different project for bots. There you can create your different bots. And the idea here is I'm going to be creating the various machine learning or AI bots, and then you can use them interchangeably. And then an user interface, something you can actually you need to be able to play the game. So either via the command line, good old console app, or I've created a web version as well. Here inside game, there's a class called play game. And this is basically the flow of the game where that happens. So just looking at it from a high level, let's zoom in here. We've got a result checker class. This is just a service I've created to look at what the result is of this current state of the game. Did you win? Did someone win? Did someone lose? Is the game still in progress? Is it a draw? And then basically we've got the game state as well. And if you think of game state, it's who are the two players playing, what's the size of the board, and I've kind of configured it a little bit, maybe too much, where you can say you want to play a 3 block tic-tac-toe, 3x3 or 4x4 or 5x5. And the other part of the state is, so it's which player's turn is it? What is the current board state? So what are the available states, etc. That's part of the board. So it captures those things. But the important thing over here is the game flow. So basically what happens is we check the current result on the state. In the beginning, it'll be an empty state. And we say, is this game done? Is it no longer in progress? So did someone win, lose? Was it a draw? If so, the game ends, and we call those methods. We update the state, which will update a few things, but we also allow just an abstract method over here. So somebody overriding this, let's say the console is able to then say, okay, game's ended. Let me to a console write line, player won the game, or you lost, or you won, or something like that. But actually the most important bit is this here, is if you haven't won, it looks at the game state, the state of the game, which player's turn is it, and invokes the make move method with the current state. And so when you're building your bot or your player, you basically override, you have to implement a method called make move, and you receive a state, and you basically have to define what your move is. And then once you've defined your move, the state applies that move, and then redraw is part of the game, where if you're doing a console app, for instance, it would need to redraw the console app to show where the new move is. So redraw and game ended, these are simply for the UI to just indicate what's happened. And this is probably overkill. But if something illegal happened, I gave you the option to also override that and maybe tell the player, hey, you've done something wrong. Quickly jumping into the game state. I'm not going to go too deep into all of this, but the idea is the game state, as mentioned just now, is it carries the state of the game. So it knows which players are playing, which players' turn it is. We also track all the states of the game. So the reason why this is important is for some of the algorithms to train in the end is you need to know all the states up to this point. So for instance, reinforcement learning or Q-learning, you'd want to get to the end state and then back propagate and feed your reward based on the ultimate outcome. So for that, the state just captures every time someone makes a move, we capture that state and we add up all the states in the end to have that available for the player to train, or the bot. The board is, which is the current board as it lies, so that's the current position or current state the board is in. And that's the most important bits. And then when we apply the moves, we update the state. It's not too much that's important here. You can go through this as well on the GitHub link. I'll post it in the video below. But the important bits is that this carries the state of the game. Looking at the board itself, there are a couple of options with regards to how to do this, and a fairly common one is actually to use a tuple. So you'd have a row and a column tuple, but I actually thought that the just having a flat array of integers works easier. It's easier to keep the memory footprint a little bit smaller, and so what I've just done is also when you're playing with a concept, for instance, you don't have to type 1,2, which is quite tedious. You just type in a single digit. So for instance, it would look something like this. Your index is 0, 1, 2, 3, 4, 5. So you've got an array of 9 items. And so if you are referring to index 3, so for instance 3, which would be that spot, that's the idea, just a flat integer array. That's the positions. So if it looks like something like this, the array looks like that, we mean that player 1 is on the first spot, nothing. Player 2, which is 0, which is confusing here because 0 in the integer actually means not been placed yet. But basically that's the idea. And we also capture the available positions and the size. So available positions, as the board goes along, it just kind of gets rid of the available positions. This is something that could have been calculated on the fly every time. I've done it to just kind of capture the state from the beginning. So you have all positions there, and then as you play, your positions kind of get removed as you place the items down. So that's what I've gone with. And there isn't too much happening over here. But yeah, so the important thing is these two properties. We've also got the size. Once again, I've made it configurable. You can have a board size of 4x4 or 5x5, for instance. But that's probably overkill. So that is the state. And once again, going back to where we played over here, the piece that really matters here is the move. And when I say matters, I mean all of it matters in the context of the game. But what matters in terms of a algorithm or a bot, a player to be able to make a move, or the best spot, exploit the best available spot, it needs to be invoked by this make move method. So I've got the concept of an iPlayer, and the interface, if you go over here, it basically, the iPlayer interface, this is the important method where we say, if you want to build a player, they need to implement the make move method, passing in the current game state, so you know what the board looks like. then you do some smart stuff and you basically return where do you want to put your marker or your piece. And that will then update the board, the game state, then it'll be the next player's turn and they'll do the same. And so when we implement the iPlayer, you'll see, for instance, I've created a bot here called the random move bot. And the make move is the most important, as mentioned now. So you come in here with a state. We look at all the available positions in the current state. And now a random move bot, just for the idea here is literally it's a dumb bot that has no idea of any tactics or anything. It's just looks at all the open spots and picks a random one. That's all it does. So we list all the available spots. We generate a random index, we pick a random one, and we return that one. That's all we do. But we'll still get into how all the different bots. I'm not quite sure exactly which ones I'm going to create. So the details of which bot will do what and what algorithms we have will come down the line. So this may slightly change as we go along. But I'm just setting something up so that we can consume it as we get there. All right, so the human player is the other player, so that we've created, and this should probably move out to bots. I'll probably do that after the recording. Just move this out to bots. It shouldn't be here. And the idea is that the human player is just something where the make move will be invoked by a physical action on, by the human. So, and create an abstract class here, literally just wraps the type. But the other, and the game ended, you probably don't need, because you won't train a human player. We don't train the same way that machine learning bots train. So then you just need if you're creating a console human player, you just need to implement the make move. The rest is done. That's why the human player over here is an abstract class. So looking at the console app now, just jumping from the actual game and the bots to, let's see how we can play and how it's implemented over here. So looking at console human player bot, once again, as we saw now, the make move. I've overridden that, and over here then basically get the game state in. You got to make a move and return an int. That's all that you need to implement to be a human player. But obviously this can't just be computed and returned. We need to actually get an input. So for console, it's easy enough. We've got a console read line, and then there's really nothing special here. We take the input 1 to 9 and we just -1 to get the 0 based index. Cool. The play game. So earlier we looked at the play game class, which is basically the flow of the game, the while loop, and it looks at what's the current state. Did someone win? No. Make a move. Apply the move. Did someone win? No. Make the move, apply the move. Did someone win? Yes. End game. So that's the game. And this was an abstract class as well. And the idea here is that when we say, okay, update the board, redraw the board, whatever UI we use needs to just implement these to indicate, okay, the board's updated and make it visible to the user. And once again, the game's ended. Not as important, but you need to tell the person, hey, the game's ended, you won or you lost or something like that. Going back to the console play game, the game ended and the redraw board, those are the two that are overridden. And a legal move, I mean, as I mentioned earlier, probably overkill a bit, but there we go. And these two methods aren't really needed. I just wrapped it in print line because sometimes I might not want to have all the noise of the prints or do something extra with it. And then I just have a single place instead of sprinkling things around here. That was more for when I was troubleshooting, setting this up. But the idea is when you redraw the board, clear the console, and I literally draw the board out in the console. Good old pipes for the verticals, lines for the horizontals, and then over here, this is where we put the player down. If it's the value is in the position, once again, this is a flat index, so we'll look at 0 index, for instance. That would be if the value is 1. It's a constant we have. For instance, here we've got player 1 is 1, player 2 is 2, player 1 symbol is X, player 1 symbol, player 2 symbol is O or 0. So there we just print out the symbol and make it a different color just to let it stand out. But that's the idea of the game. I mean, the details here aren't that important. The idea is we override the game. This is the UI, so we need to say what happens when the game ends, what are you going to do visibly, and how do we redraw the board. This is the board, please redraw it for me. The implementation is up to now, in this case, the console. So looking at program, the entry point, we've got here, we create the proper game, and proper game is just a class where I create 2 players, and I put it in a for loop, the number of games you want to play. So either it can be a player or 2 random bots against each other, and they play, and then at the end of however many rounds you want to play, it prints out your score. And this class is really not that important, but I thought for training later I may want to have, for instance, some algorithms you might want to run a proper game in exploit mode to use the trained model, and maybe have a training game where you actually through the iterations training it. So just to have that distinction and not changing the proper and the training, that was the idea here. So it'll probably be a class I'll create soon for training, just to show that over there. So the game starts, we create a proper game, and we say play. And so let's take a look. Here we go. So the random bot put an X over there, 1 to 9. Once again, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we decide 1, 2, 3, 4, 5, put it in the middle over there, and then let's say number 2, and yeah, the random bot not being very smart, so 6, 7, 8, we put in 8. And once again, because I've got it in a loop playing multiple games, the game ended and it captured the result and started a new game. And could have probably done it better just to say, hey, you won, press any key to continue. So looking over here just at what game we played now, we set up a random bot with a 500 millisecond turn delay, and the second player was the console, the human player. And we could then actually just, the great thing of this play game is you can put any players in there. You can play 2 humans against each other, you can play 2 bots against each other. Let's do 2 bots, the 2 of them play together. Let's just make this bigger. There you go, and somebody won. Random spots, and somebody won, etc. And eventually this will print out a score. Obviously if you're training, we won't have the delay, but that's just to make it easier to actually see what's going on when the bot plays. Lastly, because over engineering is something I do, is I decided to create a web front end as well. And what better place to try out, play around with Blazor a little bit, so I created a Blazor WebAssembly application. And the reason I went for the WebAssembly is that I can actually run my C# logic, all this logic on the browser, on the front end, on the client side, and not have to, you know, do requests and to try and do some either REST endpoints, which, you know, to say make move and then go over the wire and then do something on that side and keep state on the server. And remember, you could have multiple clients. Once again, over engineering this if you're going to host it, which I did, but looking at the if you're going to track state on the server side, you're going to have to then know, okay, this client has got this state and that client's got that state, and either via REST or Signal R or something like that, you're going to have to communicate and make sure you keep up with the state. So WebAssembly seemed like the perfect opportunity here. All that the site will do is it will basically the client will download the binaries, and then all the gameplay will happen on the client. And this is beautiful. I mean, it's amazing how the thought of not having to write JavaScript on the client side, but actually .NET. For me, this is a little glimpse of paradise, to be honest. Looking at some the class over here, this is where I just set up the board, and then this is all. The C# is all happening on the client side, so it's a single page application basically, and there are currently no API. There's no API backend for this. It literally is just load up the app and run everything on the browser. So and you'll see this gameplay is very much the same as the console app. There are a few nuances, extra methods, for instance, you know, update the certain class based on the result and things like that, because I'm sure there might be easier ways to do this. For me, styling is hard, so bear with me as well. But the idea is, once again, we've got the make move, we've got the redraw board, the game ended, but we create a web app game, same as we created a console app game. And basically this just captures the actions. So when we said redraw board in the console app, we would draw the pipes and the dashes and the zeros and the X's with the console writes. For the front end, basically for the web app, we take all the positions and we set the properties, because it's two-way binding, back to the Razor. So total spots, the positions, what are the results, etc. These properties are all bound. Sorry, well, they're not two-way bounded. These are just one-way binding. But then the idea is the properties get updated, and then we just indicate that the state has changed, and basically you end up playing on the front end. So on the browser, rather than needing the server with the web app. And literally the only reason I created this was that the console app is hard, and especially once we've got some trained bots, really want to actually send it to a few people to see, can you crack it, can you beat it? And giving them console app is just painful. So for instance, now you load it up. Here we're going to have multiple bots. We'll see how far this goes, which bots I'll end up creating. But for now, I've only got the random bot, and basically it says it's my turn. I'm O, so I'll do that, and I'll lose the game. There we go. You lost. And yeah, that's the WebAssembly. And the beautiful thing is this is all happening on the client. So restart game, I'm not hitting the server at all. So if multiple users end up wanting to play this game, then yeah, there's no real load on the server besides the initial loading of the binaries. I've basically taken this game and I've hosted it. So if you go to GitHub, you'll see that there's a public repo. So you're welcome to clone the repo, fork it, download it, do whatever with it. And those things over there, and I've also created some workflows to deploy it. And my deployment that I've chosen is the Azure Static Web Apps, and the Azure Static Web Apps are really nice for those web apps without those single page applications where you want kind of a CDN front end readily available in your region, and then the back end is essentially just data fetching with APIs. So a typical single page application. So your in the past, what we've needed to do before the Azure Static Web Apps, it's a fairly new service, is you basically create a CDN, and then you host it in a storage somewhere, and then you point maybe your index, your HTML files with your JavaScript, your static files are on like maybe Azure storage, and then the CDN would look at that storage and serve it up and push it to all the edge nodes. But all of that's just made a little bit simpler with Azure Static Web Apps, and you get a whole host of different functionality which I haven't used, or probably don't know the ends of what you can really do with this thing. But it's fairly easy to deploy to it. You literally just take your files you want to deploy and just put it there, and it's highly available and in various regions, and it's very configurable as well. So the workflow that I've created is to deploy there, and once it's deployed, I've then also just registered this domain, TicTacToe.filteredcode.com, and that now over here I choose random bot, and this should be exact same version I lost against a random bot. That's not a good start. So let's try a little bit better. U1, and this should also work on a mobile version, assuming that my CSS was half decent. Yeah, cool. So that is that. I'm happy to share a little bit more about the hosting side of things. That wasn't the intent of this. The web side of things, the WebAssembly, the Blazor, well, GitHub, you got to store your repo somewhere, but the Azure hosting as well. That's all just extras to make it available. So please feel free to check it out and play against a random bot. And once I create new bots, they'll be available on the homepage over here, and see if you can beat them. The idea now is we've laid the foundations. We've created an easy way to create a new player, and now it's time to get into the meat and potatoes where we actually create the bots.